This is a breakdown of successful machine vision applications. Successful machine vision applications have these three items done correctly. Notice that software tools and algorithms did not make the list. Much like a three-legged stool, machine vision success depends on lighting, optics, and material handling. If you don't have any one of these, the stool will fall over. To continue the analogy, if someone were to actually sit on a stool like this, they might have a bad time. To make a robust system, these legs could use some support. This is the analogy we're going to use from now on. Software makes the three legs that support success even stronger. It helps make the system more robust. Software holds lighting, optics, and material handling in a frame to support your application. This foundation that the stool is resting upon is a repeatable high contrast image. And the foundation of that pad is a well-defined project scope. What makes up a good project scope? Every machine vision company seems to have their own application checklist because they work. These are used to help get all the information early so that you can select the proper camera and lens and get a list of lights to try. One of the most important and most elusive items is figuring out what actually makes a bad part. So looking for holes is not really good because do they have to be perfect circles? Do we have to measure the size, the diameter? Do we have to check the locations? A good definition would be the part width is 15 millimeters plus or minus 0.5. Start with how many different model numbers or part types is this line going to produce? If the part is nested, consider the case where it's not fully seated and the angle changes. If the parts are on a conveyor, can they be double stacked? If there aren't any measures to prevent it, there will be double stacking. We're all using software so much we tend to focus on it. By focusing on it, we're missing the big picture. Let's explore these three legs that support success. To butcher a phrase from real estate, the three most important things about machine vision are lighting, lighting, and lighting. Please bear in mind, the best we can do on paper is to come up with some lighting techniques to test. We can't guarantee without trying it which lighting technique will offer the best contrast. When solving a machine vision application, you figure out what kind of lighting techniques to test, and then you get a hold of lights that can support those techniques. So let's begin with a review of some of the common techniques. This is just a quick overview to show you the variety. Details are beyond the scope of this video. We've got bright field and dark field, backlighting, coaxial, diffuse domes, and flat diffuse. These images are from Daryl Martin of Advanced Illumination. Here's an overview of various kinds of lights. We've got a bright field ring light, a spotlight that could be used for bright field from above or dark field from the side, a backlight, a coaxial diffuse, a flat diffuse, a dome, another type of diffuse dome, and here's a ring light, but this one is for dark field because the LEDs are aimed toward the center of the light. Along with the lens, consider hardware filters at this stage. Selection of all optics is based on the imager size and resolution needed to solve the application. One fundamental characteristic of lenses is the focal length. That corresponds to what's shown here, whether you're zooming in on an object far away or whether you have a really wide angle. There's a variety of specialized lenses you can use to solve machine vision applications. Filters can be used to create contrast. Here's some examples. You can see the same object on the left without a filter and the right with a filter and better contrast. There are software filters also. They can increase contrast, and we're drawn to that because it is more flexible. However, if there's an overlap where your application can be solved by hardware or software filters, you'll always get better results with the hardware filter. And if you choose hardware, your future self will thank you. Material handling is often overlooked, and it's here at the end because I nearly forgot about it too. It involves some considerations such as the orientation of the part. Is it 0 or 180 degrees? Can it be any angle, or is it fixed? We talked about part presentation, if it's always flat or sometimes tilted. Because in machine vision, geometry matters. The angles of the light to the part to the lens need to be fixed, or you need to deal with those variations. Is the part going to be stationary? Is it going to be indexed below the camera and stop and then move on, or will it be moving continuously? Pictures of moving objects tend to be blurry, so we have to do things to stop the motion. Under material handlings, where I always mention, it's best to trigger the camera with a beam break photo eye. Not a diffuse photo eye if you can avoid it, and not a proximity switch because the location of the part will vary too much. In summary, machine vision success is built upon the three fundamentals of lighting, optics, and material handling, and those are held together and strengthened by the software. This is all built on a concrete pad of a repeatable high contrast image, and the whole thing built from a foundation based on a complete project scope.